All right, let's talk about something that trips up so many people in the GCSE computer science exam: logic errors. You know, those sneaky bugs that let your code run just fine, but then it gives you the completely wrong answer. Nailing these is a real game changer for your final grade, so let's break down exactly how to spot them and fix them.
So we're diving into a type of bug that's, well, it's a bit of a sneaky one. It's so confusing because on the surface, everything seems to work perfectly. The program doesn't crash, there are no error messages, but it just doesn't do what you want it to do. And that's the whole challenge of a logic error.
So what exactly is a logic error? Well, think of it this way. Your code is grammatically perfect. The computer understands every single command you've written, but the instructions themselves, the logic, leads to the wrong outcome. It's kind of like a recipe that accidentally tells you to add a cup of salt instead of a cup of sugar. You'll still get a cake at the end, but man, it's going to be an incredibly salty, totally wrong cake. That, right there, is a logic error in action. To make this really hit home, we're not just going to talk theory. We're going to pull a real case study straight from an official GCSE exam paper. We're going to take apart an algorithm, find its two hidden logic errors, and fix them together exactly like you'd have to in the real exam.
Okay, first things first, and this is a big one. Before you can fix any bug, you have to know what the program is supposed to do. This is always step one. If you don't know the destination, how can you possibly know if you've taken a wrong turn? So here's the mission for our little piece of code, laid out clearly in the exam question. First, it needs to take in two numbers. Second, it adds them up to get a total. Third, it checks if that total is between 10 and 20, and that includes 10 and 20. If it is, it should print success. And finally, if it's outside that range, it should print warning. Simple enough, right?
Okay, so here's the code that was submitted. And if you just glance at it, it looks pretty good, right? It seems to follow all the steps we just went through. But trust me, there are two critical mistakes hiding in there. Let's go find them. All right, let's hunt these bugs down one by one. The first one, it's a classic mix-up, a calculation error that's super easy to miss if you're rushing through the code.
Let's zoom right in on line 03. It says total equals num1 plus num1. See the problem yet? The whole point was to add the two different numbers the user typed in, num1 and num2.
This slide just lays it out perfectly. On the left, you've got what the code is actually doing. It's taking that first number and just adding it to itself. It completely ignores num2 altogether. But on the right, that's what we wanted it to do, add num1 and num2 together. It's such a tiny typo, but it totally breaks the entire logic of the program.
Okay, bug number one, squashed. Let's move on. Time to hunt for the second error. Now this one's a little bit sneakier. It's all about how the program makes its decisions.
So for our second error, let's take a look at line 04. This is our big if statement, the one that's supposed to be checking if the total is in the right range. It just says, if total greater than 10, then. What's missing here? What part of the rule isn't it checking?
The problem is, the code is only checking one half of the rule. It's just asking, hey, is the total 10 or more? And sure, a total of 15 passes that test, and you get success, which is great. But what about a total of, say, 50? Well, 50 is also greater than 10, so it also gets a success message. And that's just wrong. The logic completely forgot to check the upper limit, that the total also has to be less than or equal to 20. Okay, we've found our two culprits. Now for the most important part, especially for your exam. How do we fix them to get full marks? This is where we look directly at the official mark scheme to see the exact answer they're looking for.
For that first error, the fix is exactly what we figured out. The mark scheme says you need to state the line number, which is 03, and then provide the correction. And look at the wording. Total equals num1 plus num2. Getting that syntax spot on is how you get the mark.
And for that second error on line 04, here's the official fix. If total greater than or equal to 10 and total less than or equal to 20, then. See how it uses that and operator? That's what creates a complete condition that correctly checks both the bottom and the top of that range. That exact line of code is what the examiners want to see. So, we've just walked through a real exam question step by step. Now let's turn that whole process into a powerful debugging toolkit that you can use every single time you face a logic error.
So here are your key takeaways. First, and I can't say this enough, you have to be absolutely crystal clear on the goal. Second, read the code line by line, not for what you think it does, but for what it literally says.
Third, constantly compare what the code is doing to what it's supposed to do. Fourth, a great technique is to do a trace table. Just run through the code with some sample numbers like 5, 15, and maybe 25 to see exactly where the logic breaks. And finally, as we saw, you've got to know the exact syntax required by the mark scheme. That's where the marks are.
And there you have it. We've successfully cracked this code. The cool thing is, these principles, understanding the goal, reading literally, and comparing against the objective, can be applied to any bug you ever encounter. So the only question left is, what's the next bug you're going to fix?